EMT, electrical metallic tubing, is a recognized and approved raceway for electrical conductors according to the National Electrical Code, or NEC. Its use is permissible for runs between an electrical panel and ductwork. The NEC doesn't mandate the use of mineral insulated or MI cable for the specific application. While an inspector might express a preference for a MI cable, that preference doesn't supersede the NEC allowance of EMT. The underlying concern likely revolves around potential damage to the EMT from contact with the ductwork or other environmental factors. However, EMT is designed as a durable and robust raceway, making it suitable for such applications when properly installed. If an inspector raises concerns, those concerns should be directly communicated to the electrical contractor. The contractor, in turn, has a responsibility to ensure the installation meets all NEC requirements. Several factors are important to consider when evaluating the suitability of an EMT installation. Firstly, the size and type of EMT being used must be appropriate for the application. This includes considering the number and size of conductors being run within the conduit. The NEC provides tables such as those found in Chapter 9 that specify the allowable fill for different sizes of EMT. Secondly, the distance between the electrical panel and the ductwork influences the support requirements for the EMT run. Longer runs require more frequent supports to prevent sagging or damage. The NEC in Article 358.30 outlines the requirements for supporting EMT. Support should be provided every 10 feet, or 3.0 meters, and within 3 feet, or 0.9 meters, of boxes, conduit bodies, and other conduit terminations. Thirdly, the method of securing the EMT to the ductwork is important. The method must ensure a secure and stable connection that prevents movement or vibration from damaging the conduit. Avoid direct contact between dissimilar metals to prevent galvanic corrosion. Using appropriate straps and fittings designed for EMT is critical. Additionally, consider using non-metallic spacers or bushings to isolate the EMT from the ductwork if necessary. The presence of other factors that could potentially damage the EMT should be assessed. This includes exposure to corrosive environments, physical impact, or excessive heat. If such factors are present, additional protection measures may be necessary, such as using a more corrosion-resistant type of EMT or providing physical barriers. If the contractor can demonstrably prove that the EMT installation adheres to all relevant NEC requirements, the inspector should approve the installation. This demonstration may involve providing documentation such as conduit fill calculations, support spacing details, and material specifications. It may also involve a visual inspection of the installation to verify compliance. Understanding the relevant NEC articles is crucial for both contractors and inspectors. Article 358 pertains specifically to EMT. Article 300 covers general wiring methods and materials, and Article 310 addresses conductors for general wiring. Familiarity with these articles will help ensure a safe and compliant electrical installation. In summary, the NEC permits the use of EMT between an electrical panel and ductwork, provided that the installation meets all applicable requirements. The contractor should carefully consider the size and type of EMT, the support spacing, the method of securing the EMT to the ductwork, and the presence of any other factors that could potentially damage the conduit. If the inspector has specific concerns, the contractor should address them directly and provide documentation to demonstrate compliance with the NEC. When dealing with electrical installations, safety is paramount. Always follow the NEC and any other applicable codes and standards. When working with electricity, always de-energize the circuit before starting work and follow proper lockup/tagout procedures. If unsure about any aspect of the installation, consult with a qualified electrician or electrical engineer. Remember that electrical codes and standards are constantly evolving. Stay updated with the latest edition of the NEC and any local amendments. Participating in continuing education courses and professional development activities will help you stay informed and competent in your field. By following these guidelines, you can ensure a safe, compliant, and reliable electrical installation. The NEC is a comprehensive document, and it's essential to have a thorough understanding of its requirements before undertaking any electrical work. When in doubt, consult with a qualified professional. Proper planning and execution are key to a successful and safe electrical installation. Always prioritize safety and compliance. The inspector's role is to ensure that the electrical installation meets the minimum safety standards outlined in the NEC. By working together, contractors and inspectors can help create a safe and reliable electrical system. Consider the environment where the EMT is installed. In damp or corrosive environments, consider using galvanized EMT or PVC-coated EMT to protect against corrosion. Ensure proper grounding and bonding of the EMT system to minimize the risk of electrical shock. Use appropriate fittings and connectors that are listed for use with EMT. Avoid using smashed or incompatible components. When bending EMT, use a conduit bender to avoid kinking or damaging the conduit. Follow the manufacturer's recommendations for bending radius. Inspect the EMT regularly for any signs of damage such as dents, cracks, or corrosion. Replace any damaged conduit immediately. Keep the EMT system clean and free of debris. Dirt and dust can accumulate and reduce the effectiveness of the grounding and bonding system. When making connections to electrical equipment, use appropriate terminals and connectors that are rated for the voltage and current involved. Tighten all connections securely to prevent overheating and arcing. Label all circuits and equipment clearly and accurately. This will help with troubleshooting and maintenance in the future. Maintain accurate records of the electrical installation, including drawings, specifications, and inspection reports. This will be helpful for future reference and modifications. Always follow safe work practices when working with electricity. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Never work on live electrical circuits unless absolutely necessary, and then only with proper training and precautions. Be aware of the potential hazards associated with electricity such as electric shock, arc flash, and fire. Take steps to mitigate these risks. The electrical system is a critical part of any building. Ensure that it is properly designed, installed, and maintained to provide a safe and reliable source of power. Remember that the NEC is a minimum standard. It is always a good idea to exceed the minimum requirements when possible to improve the safety and reliability of the electrical system. Consider the future needs of the building when designing the electrical system. Provide adequate capacity for future expansion. Use energy-efficient lighting and equipment to reduce energy consumption and save money. Install surge protection devices to protect sensitive electronic equipment from voltage spikes. Inspect and test the electrical system regularly to identify and correct any problems before they become serious. Train building occupants on how to use the electrical system safely and report any problems. The electrical system is a complex and potentially dangerous system. Always consult with a qualified electrician or electrical engineer when planning, installing, or maintaining an electrical system. When installing EMT, ensure that it is properly reamed to remove any sharp edges that could damage the conductors. Use a wire lubricant to make it easier to pull conductors through the EMT. Avoid overfilling the EMT. The NEC specifies the maximum allowable fill for different sizes of conduit. Support the EMT properly to prevent it from sagging or bending. Use appropriate straps and hangers that are designed for EMT. Ground the EMT system properly to provide a path for fault current to flow back to the source. Bond all metallic parts of the electrical system together to create a low impedance path for fault current. Protect the EMT from physical damage by installing it in a location where it is not likely to be struck or damaged. If the EMT is exposed to the weather, use weatherproof fittings and connectors. Inspect the EMT regularly for any signs of corrosion. If corrosion is present, clean the EMT and apply a protective coating. Replace any damaged or corroded EMT immediately. The electrical system is a vital part of any building. By following these guidelines, you can help to ensure that it is safe, reliable, and efficient. Remember that the NEC is a living document that is constantly being updated to reflect new technologies and best practices. Stay up to date on the latest changes to the NEC by attending training courses and reading industry publications. By staying informed, you can ensure that your electrical installations are always in compliance with the latest codes and standards. When working with electricity, always be aware of the potential hazards and take steps to mitigate those risks. Your safety and the safety of others depends on it. EMT offers several advantages over other types of conduit, including its low cost, ease of installation, and durability. It is also non-combustible, which makes it the safe choice for use in buildings. However, EMT also has some disadvantages, including its susceptibility to corrosion and its limited capacity for conductors. Consider these factors when selecting the appropriate type of conduit for a particular application. The NEC provides detailed requirements for the installation of EMT, including the type of fittings and connectors that must be used, the spacing of supports, and the grounding and bonding requirements. It is important to follow these requirements carefully to ensure a safe and compliant installation. When installing EMT, it is important to use the right tools and equipment. This includes a conduit bender, a conduit reamer, a wire puller, and a set of screwdrivers and pliers. Using the right tools will make the job easier and safer. Before starting any electrical work, it is important to disconnect the power to the circuit. This will prevent electric shock. Always test the circuit to make sure that it is energized before touching any wires or equipment. When working with electricity, always wear appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. This will help to protect you from electric shock and other hazards. If you are not comfortable working with electricity, it is best to hire a qualified electrician. An electrician has the training and experience to safely and properly install electrical systems. Electrical work can be dangerous. It is important to take precautions to protect yourself and others from electric shock and other hazards. By following these guidelines, you can help to ensure a safe and successful electrical installation. Remember that the NEC is a minimum standard. It is always a good idea to exceed the minimum requirements when possible to improve the safety and reliability of the electrical system. Consider the future needs of the building when designing the electrical system. Provide adequate capacity for future expansion. Use energy-efficient lighting and equipment to reduce energy consumption and save money. Install surge protection devices to protect sensitive electronic equipment from voltage spikes. Inspect and test the electrical system regularly to identify and correct any problems before they become serious. Train building occupants on how to use the electrical system safely and report any problems.